If you have ever seen this sum, known as the famous Ramanujan's infinite sum, then at first it feels completely wrong. Like, how can this thing ever be true? Like, how can adding positive numbers ever result in a negative number? And how adding natural numbers can result in a fraction? In what kind of world, if you have one apple, then you add 2 apples to it, then you add 3 apples to it, and so on, you get a negative 1 by 12 apple. What does this even mean? This equation should be absolutely wrong. But then you see the name Ramanujan tied to it, the man who knew infinity. And then you see this sum being used in physics, like string theory. And then you are forced to believe that somehow, if some genius mathematician is saying it, people are using it in physics, then somehow, in some way, this equation might be actually true. Like, adding positive number can get us a negative number. Adding apples together can get us to a negative 1 by 12 apple. And even if you look at its complicated proofs which prove that this sum is true, even after that, there is some uncertainty in your mind about this sum. So till the end of this video, I will try to resolve this confusion. I will try to get you the feeling why 1 plus 2 plus 3 and so on till infinity is equal to negative 1 by 12. Or in other words, we will try to make sense of Ramanujan's infinite sum. Hello geniuses. So in this video, my goal is not to just prove this sum and say, see, it holds, this sum is true. No, my goal is to get you the feeling why this sum is actually true. Now if you want to look at a really simple proof of this, you can look at this number file video. But remember to keep things really simple and to keep it for a general audience. Number file oversimplified the things and kind of conveyed the wrong idea. The proof that they show in this video is not entirely mathematically accurate. The reason is explained in this video, okay? So you can watch this video, but be careful too. The real proof of this requires some advanced mathematical techniques known as beta function regularization and Ramanujan summation. But for a normal person, these are some mathematical hocus pocus which proves that this sum is this. But intuitively, how? So this is why in this video I am not going to prove this sum. With an analogy, I want you to intuitively understand what's happening here. And for that, I will prove something else. Okay, so now listen to this extremely carefully. I am going to prove this. See, 0.999999 and so on till infinity is equal to 1. I am not saying approximately equal to. I am saying it absolutely equal to, straight up 1. Now I am going to prove this and try to see what's happening here. So suppose S is this, 0.999 and so on till infinity. Now if we multiply S with 10, it would be 9.999 and so on till infinity. The decimal shifts, okay? Now let's do 10s minus s. That is 9.9999 and so on till infinity minus 0.9999 and so on till infinity. So 9s is equal to 9 and s is equal to 1. So see what just happened here. We proved 0.9999 and so on till infinity is absolutely equal to 1. Not approximately, straight up 1. Okay, now for a moment, let us remove this infinity from here, right? Let's try to prove this same thing this same way without this infinity. In place of infinite nines, let's have 3 nines. So s is equal to 0.999. Then 10s would be 9.99. Okay, so 10s minus s is equal to 8.991. So 9s is equal to 8.991. S is equal to, divide these two and you get 0.999. This is not equal to 1. So how in the first proof we were able to prove it exactly equal to 1? What was different there and not here? And if you have thought it correctly, you have got the intuitive sense, that is infinity. In the above proof, there was the freedom of infinity. Okay? See, infinity gave us the freedom to slide the decimal. And there it was not defined like how many nines are there. If I ask you how many nines are there, infinite 9. What do you mean by infinite 9? How many? Infinite, not defined. See, infinity is not a number, it's a concept. Okay? And in the above proof, we used this infinity as a concept to apply a mathematical technique. We can call that mathematical technique anything like beta function regularization or Ramanujan summation, anything. So what we just did was something similar to handling infinities. See, always remember this, infinity is not something defined, it's a concept. And the way you handle this concept, the way you interpret this can help you prove weird things like 0.9999 and so on till infinity is exactly equal to 1. So the same thing happens in that proof too. This proof is not valid till there is this infinity symbol attached to it. Remember that. Even if this sum goes to billion, trillions, even the biggest number you can ever think of, Google, anything, this sum will not result to negative 1 by 12 till you add this infinity. As soon as you add this infinity in here, this gives you the mathematical freedom to handle infinity as a concept. You can slide these series from here to there, and the thing which remains at the end gives you the answer. So that is what happens when we try to prove things with series involving infinities. We handle them very intelligently, like we did in this 0.999 equal to 1 proof. We handle them very intelligently to prove things that doesn't make sense physically. Because see, infinity is nothing physical. There is no thing in reality as infinite. You can never have infinite apples. So one thing I want to tell you is this. See, this series 1 plus 2 plus 3 and so on till infinity is actually a divergent series. But in some places, if you want some answer, if you don't want this series to blow up to infinity, then you can use some mathematical techniques to handle this infinity in some intelligent way. Call it beta function regularization, call it Ramanujan summation, but it's some weird mathematical technique which is helping us to handle this infinity in some intelligent way to get to a finite answer. And if we do this one specific way, you get this negative 1 by 12. This specific sum is